Let me quickly take you through how to draw structures. Draw the structural formula for each of the following. So you have been given the name and you are required to draw the structure. So here you start with the parent name. The parent name here is heptane. Heptane means 7 carbon atoms. So heptane, so you write 1, 2, 3, 4, 5, 6, 7. Heptane means 7 carbon atoms. And then you will now start numbering. This is carbon number 1. You can give this carbon number 1, number 2, number 3, 4, 5, 6, 7. So on carbon number 2, there is methyl. So carbon number 2, there is CH3. But since you were told to give structural formula, don't write it like this. You need to write it open structure like this. H, like that. Because it should be a structural formula. So here we have this, and then the rest you add hydrogen atoms. So here you will put hydrogen, 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 all the way. So let me quickly, you will do this one. Let me do number C. We have 2,2,4 trimethyl pentane. 2,2-trimethyl pentane. So the first thing we do is the parent name. The parent name is pentane. So pentane means 5 carbon atoms. So 1, 2, 3, 4, 5. And then we start numbering here 1, 2, 3, 4, 5. So on carbon number 2, again number 2, there is methyl group. So CH, H, CH, CH, H, H, there is a methyl group. And then carbon number 4, there is another one here. There is a C, H, H, H. CH3 in open structure, this is how we write it. And then the rest, you add the hydrogens and you are done. Number D, 2,3-dichloro. So we have the parent name is butane 1, 2, 3, 4. And then on carbon number 2, there is chlorine. So here we will put Cl. Again on carbon number 3, 3 is here, there is another Cl. And this one is 2,3-dichloroputane. So preparation of alkanes, it is important to know the reagents that are used, very important. So reagents used to prepare alkanes, we have sodium hydroxide, which we call soda lime, and appropriate alkanoate. So for methane, to prepare methane, we use sodium ethanoate. Sodium ethanoate. That one is CH4, methane. If you want to prepare, so sodium methane plus sodium hydroxide, you will form methane. In case you want to prepare ethane, you will use sodium propanoate. In case you want to prepare propane, you will use sodium butanoate plus sodium hydroxide. Alongside the gas methane, CH4 that is produced, there is sodium carbonate. Sodium carbonate is produced, or is produced. So these are some of the things you need to know: the reagents and the equation, how to write the equation. Physical properties, I want to give you one that the melting point at the boiling point of alkanes increases with increase in the number of carbon atoms. An increase in the number of carbon atoms increases the intermolecular forces, which increases the melting point and the boiling point of alkanes down the homologous series. Alkanes undergoes 2 important reactions, that is combustion, burning. When the methane is burnt in excess air, it burns with a blue flame that does not produce smoke, and this is the equation. So when you burn an organic compound, N organic compound, what is produced is carbon dioxide and water. Very important. This one is going to assist us in the flow chart. So methane burns in air, that is oxygen, to produce carbon dioxide and water. Another chemical reaction that alkanes undergo, here we are going to use methane, is substitution. This reaction occurs only when there is the presence of what? Of ultraviolet light, that is the sunlight. So substitution is where a reaction in which one atom or a group of atoms in a molecule is replaced. Actually, there is no chemical reaction. What happens here is the replacement. So here we have CH4 reacting with chlorine. So what happens? One hydrogen here is substituted with one chloride ion to form chloromethane, to form this, right? And then HCl is formed. So this one thing you need to note the condition. The condition is that there must be ultraviolet light for a substitution to occur in alkanes. It is important to know at least the two uses of each organic compound you have learned. Uses of alkanes is that methane is used as fuels. Also, alkanes are used as sources of hydrogen during cracking process. We have hydrogen produced. Isomerism. What is isomerism? We have isomerism in alkanes, but let us first understand what isomerism is. Isomerism is a situation where two or more compounds have similar molecular formula but different structural formula. So we will have a compound, for example, butane, having the same molecular formula but different structural formula. That one is what we call isomerism. So during isomerism, we form compounds we call isomers. Yes. So what is an isomer? An isomer or isomers are compounds that have the same molecular formula but different structural formula. You can be asked, for example, to draw all isomers of pentane. So isomers. First, pentane itself, when you draw, remember pentane is C5H12. This is the molecular formula. Molecular formula of pentane has 5 carbon atoms and 12 hydrogens. So let us draw the first isomer. The first isomer will be the open structure of this. 1, 2, 3, 4, 5. And then you put the hydrogen where they are supposed to be. So this is the first isomer of pentane, and we call it pentane. Right? The next, now what I want you to see is that this compound, this one here is a methyl group, CH. Now this one is a methyl group, CH3. This is C1, 2, 3. This one is so we remove one methyl group and move it inside. But no, don't put on the first carbon atom. You put it at least the second or third. So we want, tunataka tutoe hii ambayo ni CH3 tuisongeze kwa carbon ya 2 ama ya 3 hapo katikati. Namna hii. So nataka nitoe hii, nikitoa hii itabaki 1 2 3 4. So itabaki 1 2 3 4. Nishatoa hii. Na hiyo yenye nimetoa ninaiweka hapa CH3. Sawa? Nimeweka hapa CH3. Zingine zenye zote zimebaki, weka hydrogen atom. Weka hydrogen atom. So ukiangalia hii jina yake itakuwa 1 2, itakuwa 2 methyl butane. 1 2 3 4 itakuwa 2 methyl butane. 1 nikianza kuhesabu kutoka hapa 1 2 3 4. Sasa hii they have the same molecular formula but different structural formula. Utajuaje they have the same molecular formula? Hesabu is how many carbons? 1 2 3 4 5. 5. How many hydrogen? 1 2 3 4 5 6 7 8 9 10 11 12. 12. You see? Bado kuna ingine. Again, ukisongeza hii hapa, china itachange. So you move this one here, that is another isomer. That one is going to be 1, 2. No, it will not be another isomer. So I can remove another one here and put it here, like this. 1, 2, 3. If I remove this one, we will have 3 remaining. 1, 2, 3. 1, 2, 3. Sasa ninachukua hii yenye nimetoa hapa niweka hapa CH3. Na ile yenye ilikuwa niweka hapa CH3. Halafu hii nyingine niweke hizi zenye zimebaki. Hydrogen, 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 hydrogen. Ukihesabu zote itakuwa 3, 6, 7, 8, 9, 10, 11, 12. 12 hydrogen, carbon, 1, 2, 3, 4, 5. 5. The same molecular formula but the different structural formula. These are called isomers. And this one is going to be 2, 2 dimethyl 1, 2, 3 propane. So pentane has 3 isomers. 1, 2, 3. Teseka nimeteseka, aso limeaso, wala leo